So good Thursday afternoon, everyone. Welcome to lecture 23, normal distribution in maths for construction. So the review, right? This is also a review from last lecture. Here, we talk about the standard normal variable and probabilities and these things. Standard normal variable is the variable which has a mean of 0 and a variance of 1, right? Variance is sigma squared, right? Sigma is standard deviation. The curve is very hard to integrate, so we use tables to find the area. So phi of z is the probability that z is less, phi of a, phi of some value, if I say here phi of a, is the probability that z is less than a, and you use the tables to find that. What we want to do is we want to talk about using a normal table to find a given phi of a or a probability. Right? So here they say, this a some value, right? If you look at all of these probabilities here, it's greater than 0.5. So probability that z is less than that value of a is greater than 0.5. So obviously a has to be a positive value. Okay, that again you have to draw a sketch. So if phi of a is 0.946, this is phi of a, probability z is less than a. This value here, 0.9, that is greater than 0.5, a had to be positive. If this probability was less than 0.5, a would have to be negative because the area under the curve is 1, the total area under the curve is 1, and the curve is symmetrical. So a probability greater than 0.5 is an area greater than 0.5, which is an area greater than half the curve. Since the area is to the left because it's less than, a needs to be positive. Now, how you would figure out what a is if I tell you the probability is 0.9406? Well, you have to go in the table. Go in the table here and look for 0.9406. Where is that? Look, I've seen 0.94 here by 1.6. 0.94. Well, look at here, 0.9406. So this is 1.56. 1.56, right? So you could say that directly from the tables for that one. From the tables, so when a is what? Can't remember what I just say. Let me see. 0.9406. 0.9406 here. So that's 1.56. So directly from the tables is 1.56. Okay. We'll do the other ones. It's not always be so easy. Phi of a is 0.9579. Where could we find 9579? So look, 9582, 9573. We can't find 9579. It's between these two values. It's between 1.7, 1.62 and 1.63. 79, 94, 79 is there. So you need to figure out what value you need to add to 74 to get 79. We need to add 5. So if you come across here, look the 5 here that we need to add, right? So 9479 is 1.62 and then 5, right? If this 5 column here says to add 5 to 9474, 9474 and 5 is 9479. So that's 1.625. right? 9579. So we could say a little more here, right? We cannot get the exact value of 0.9579 directly in the table, but we can get 0.9574 at the, what is the Z value? At the Z value of 1.62, right? Then we can add 0.0005 0.9574 to get 0.9579. So the third decimal place is the 5 column. Is the leftmost 5 column, right? That's why you get this decimal place of 5. You get this third decimal place of 5, not because we need to add 5 in. It's because what we need to add is in column 5. So I need 9579. I get I need 9579. So 9574. And to get 9, I need I make a mistake. I was looking at 94, is 9579 I need. So that's 9573 and 6. Okay. So 9573, if I add 6 to 73, I'll get 79. So that's 1.72. 1.72 and a 7. Right. So the 1.7 will give the 9573. And we had to add 6 to that. The 6 we need to add is in the 7 column. So here 1.2, 1.727. So 9579, 9573 here, me put it to the bottom of the page, 9573 and 6. 9573 is 1.72. And if you add in 6, 1.727. Right? So I think you all understand the kind of effort you have to put into this to get the answers, right? So what to do is try the last two and see what you would need to add, which columns you would need to add, right? If you have more than one value, add the smallest one. So if, you know, like you watch your table here and you see like these 3 2s here, 2, 2, and 2, you know, then if you could add multiple to decimal places, add the smallest one, right? You see like up here, you see 2, 2, and 3, like if you could add 2 and 2 to this 9817, if you wanted to get 9819, right? Then you could use any of these two here. So use the smallest one, right? I hope that makes sense. Try this now as practice. Sorry for the error before. Okay, so we want to get 9832. 9832. We'll look at 98, 26, 30, and 34. 9832 is between these two values here. So it's 2.1 something. So I'm going to put it at the bottom here so we can see properly. So 9830 is 2.12. And what do we need to add to 30 to get 32? We need to add 2, right? So you see, any of these values could be used here. So use the smallest one, right? The 4. So that's 2.124, right? 2.124. So you could take this reasoning here. Right? So we know this is 2.124. And it's 9832 we want. 9832. Now we can't get 9832. But we could get 9830 with a Z value at 2.12. Then we could add a 2 to 9830 to get 9832. The third decimal place had to be in the 4th column, the leftmost 4 column, because it's the leftmost 4 column that have the 2. You take any smallest one. You can use 4, 5, or 6, right? But we're using the 4. That's this 2 down here. So 2.12, 2.124. Right, 9030 to 2.124. So that's nice there. What about this one? 99042. So let's copy this solution here, right? So 99042. Let's look here and see that. 99. So 99036. 99036, right? I need 99042. So 36. And how much could give 42? 36 and 4 is 40. So 36 and 6. But you see, we're not getting a 6 here, right? So we could pick the one closest to it, which is the 5, right? Bring us down now. So 99042. So I'm saying 99,036, which is this one here. And if we go in this column here, the 5, right? So that is 2.342. So all this is 2.3, you know. These 3 rows to the bottom here is all 2.3. So this is 2.34 here. So 234. And then we'll pick the 5 because the 5 is the closest by 2. 2.342. So the answer is almost 2.342. We could get 99.36. Get 90.36 minus 2.34. Right? 2.34 is 99,036. 2.34 here, 99,036. And I need a 6. But if you look at this row here, second to last row, I could only get a 5. The 8 too big, too far away. So you'll go with the 5. Right? So we could add 6 to get so 99,036. You could add 6 to get 99,042. So we cannot find a third column. A third decimal place column that has 6 in it for row 2.34. Right? We take the closest we take the column that gives the closest probability of we wouldn't get 42, we'll get 41, right? That's column 2. So we you take the column 2 that gives it closest probability because you're adding 5 instead of 6, right? If you add 5, so take column 2 where we could add 5 to 936 to get to give a closest probability of 41. So mean that the third decimal place is in the 2 column, right? So you'll get 2342. And again, this exact value, we get 99041. 2342. So 2.34. And then you add a 2, 5. So if you add 5 to 36, you'll get 99041. It's very close to 99042. So hope you all understand that. So look at example 2 here. Be careful with the direction of the more than or less than sign, right? If probability that z is less than a is this probability here, what is a? Use the tables to find out. But look at these second and third one, z is more than a. So remember here, the purpose of drawing a diagram is to figure out where is the area they're asking for? Is the area to the left or to the right? Okay. And where is the value? Is the value to the left of the y-axis or the right of the y-axis? Okay. So we see from last time, we had different diagrams, like these two diagrams here, or these two diagrams here. Where is the area? Is it to the left or the right? And where is the value that you're talking about? Is the value to the left or to the right? So it's 4 possibilities. This is a left value on a left area. This is a left value on a right area. This is a right value on a right area. And this is a right value on a left area. Okay, we have 4 possibilities. So the purpose of drawing a diagram for these 4 questions to figure out which possibility is this. And then you use the symmetry properties of the curve to figure out what the probability is, right? So try these 4 examples here. This is very important for you to try. It will help you to understand how it is you're getting the things, rather than just watching me do it and looking and trying to watch your notes after, right? So the first question, probability that z is less than a is 0.9693. This probability is more than 5, right? So let me put this here. Probability is more than 0.5, which means that and the area is to the left, right? Since it's less than, is to the left. So the area to the left is greater than 0.5. So this means that A is positive, right? And we have a situation where that A is positive. We have a situation like this, this diagram here, right? Let me see if I have any diagrams where I could use this, right? So we have this situation here for this question, right? So this A value could be found directly from the table, right? This means that so 5A is 0.9693. So 5A is as well. Remember, 5A is the probability to the left of the value. The probability that Z is less than A, right? Z is the value of the normal variable, and the probability that that is less than A is 0.9693. So that's what the table really gives. The C table gives phi of, they're calling it phi of Z here, but I don't want to confuse lowercase z and common z, right? So what we're looking for, we're looking for 9693. Where's 9693? Look, 96, look to the bottom here, look 9693 here, flush. So that's 1.87, 1.87, right? 1.87 from the table. A is equal to 1.87, right? That's how you do that question there. This question now. Probability A is equal to 0.3. Now it's more than A, that Z is more than A, right? So it means the area to the right of some value is less than 0.5, right? The area more than the area to the right of some value is less than 0.5, meaning it's a smaller area. Which diagram here looks like that could be the case? The area to the right, so forget about this one, is this one here or this one here? Sorry, the area to the right, okay? So it's these two diagrams here, the area to the right. But the area to the right is a small value, less than 0.5. So that can't be this bottom one, that had to be this one here, right? The area to the right is less than 0.5, meaning less than half the curve. So this is a possibility here that we want to get at, right? So I'll just use this for now, right? I'll just use the diagram for now. Right? I mean, it's not one. We know it's not one, it's A, right? But we're just using this diagram for now. The area to the right since it's more than so it means that A is positive, right? So, but phi is not 0.3802, right? So let's see what we get here. Let's see what we could say. So phi of A, which is the area less than A, is really 1, which is the probability that Z is less than A, is 1 minus, remember the whole area is 1. Right? So if the probability is more than is 3802, then the probability less than is 1 minus 0.3802. What's 1 minus 0.382? 3802, right? That's 6198. Right? So now I know phi of A is 6198. I could just use these tables to get A. Where is 6198 in the tables? 61, look 61, 79. I have 61, 79. 71 on how much make 9? 79 on how much make 98? 19. So look the 19 here, right? So 0.305. 19 is a 5 column. 0.305 from the tables. Oops. All right, so 0.305 gives 6198. Let me show you 0.30 is 6179, and the 5 is 19. 19 and 79 is 98. So 6198, which is what we have here. So that's how you would do that. So this question here, the third one, let's move it down. What you notice about this here? Probability is more than 0.5 and is an area to the right, right? So the area to the right, since it's more than, is more than 0.5. So if A is here, you have to slide A to the left at this origin for the area to the right of it to be more than 0.5. So A had to be negative, right? So what's the image we have for that? Something like this, right? A is a negative value. So we could write so probability that Z is more than A is equal to the probability that Z is less than minus A by symmetry, right? So what probability Z is more than A, which is what they gave us. If we know A is negative by symmetry, that's the same as the probability that Z is less than A. See here? Where minus A, if A is negative, then minus A is positive. But probability that Z is less than minus A is phi of minus A. So phi of minus A is 7367. Where is 7367 on this graph? 73. So look here, 7357, and you add 10 to get 7367. So there's 0.633, 0.633, right? So negative A is equal to 0.633. Right? So A has to be negative, which makes sense. That's what we concluded up here. So we know A is negative, and we found it using the symmetry of the curve, right? As well as where you think it would lie. Okay. Hope you all understand that there. What about this one? Probability that Z less than A is a real small value. There's a small value here. Okay. So let's see. What could we say? The area to the left is area to the left, since it's less than, right? Is less, right? Way less than 0.5, right? So the area to the left is very small. So who has an area to the left? This guy. For this area to be less than 0.5, I have to slide this A quite on the left of the origin. So A has to be negative here. This means A is negative, right? So what diagram do we have, basically? We have this diagram, right? Z less than A is a small area. A has to be negative, right? So let me duplicate this here. Right, so what can we say? Probability z less than a is phi of a, right? Phi of a is 0.070793. Okay. Now the table doesn't give values for negative a, right? Doesn't really give values for this, like 0.07, like you can't find 0.07 inside of here. It starts from 0.5 up here. Okay, so the other find an interesting way to get this, right? So phi of z is less than phi of a is a small variable, but we know this is negative because the tables don't have any values at all. But what about phi of negative a? What is phi? If this is a here, what is phi of negative a? Phi of negative a is we ought to kind of draw a diagram like this here. Right? Okay. This would be negative a, right? So hold on. So we concluded that a is negative and phi of z is this small probability here, which is less than 0.5. Now, using symmetry, if we reflect this a in the y-axis, we will get this diagram here, right? Minus a, and the probability that z is more than minus a is the same thing, 0.0973, right? So look at these two diagrams here, the reflections of each other. So the probabilities are the same, but this one is a and this is minus a here, right? So probability as z is more than minus a is the small value. Now what is the probability to the left? Probability to the left now is z less than negative a. And that's 1 minus the small probability here. The probability in white is 1 minus the probability in red. So probability of z less than negative a is 1 minus 0.079, which is 9207. Now, the probability less than something, negative a is positive, a is negative, so negative a is positive. So this is phi. This area is phi. Phi of negative a is 9207. Where is 9207 in the curve? Look, 9207 here. 1.41. 1.41. So negative a is equal to 1.41. That means a is negative. Okay. So you see how many diagrams are drawn to understand this question, right? This question here, 1, 2, 3 diagrams, and I read the table to figure out what is the right value. So I hope you all understand this. So we did a lot of questions today, a lot of diagrams, right? We want to talk about something new now, right? So we saw how to use the table to find phi of a, and we did lots of questions with this. Where you was asking yourself, what is the probability that z is less than or more than some value? We saw how to do that last lecture. Today's lecture, we saw that if you know what the probability is, if you know the probability that z is more or less than a certain value, what is the value? So it's like you're reverse engineering the value. So that's what we did today. And now we're gonna talk about any normal variable, right? This all the time we're talking about the standard normal variable, but you could use the standard normal tables for any distribution. So if you have some variable x and x follows a normal distribution with mean, mu, and variance sigma squared, right? That's how you read this. So the mean is not 0 and the variance is not 1, right? But x is some normal variable that follows some two different parameters. What we standardize, right? We call standardize x, meaning you convert x to the normal variable by first subtracting the mean and divided by the standard deviation. So we have this very important result here. If x follows a normal distribution, mean, mu, and variance sigma squared, then we could convert that or standardize it to a z distribution where the value is x minus mu over sigma, okay? I'll do some examples to show you what it is we're talking about, right? So let me get an example here. I'll show you. So example 3, and we have a solution 3, right? We have to draw some diagrams for this. So packages from a packet machine have a mass, which is normally distributed, right? Mean 200 and the standard deviation is 2 grams. So we have a normal distribution, but it's not mean as 0 and mu it's not mean as 0 and variance of 1. The variance is 4, which is standard deviation squared, and the mean is 200. So we can't use these tables to do 200, right? Where you're gonna find 200 and here, all these values is 0.5, 0.61, 2 point something, you know? We can't use 200 on 2, right? But we standardize it, right? So they want to find these probabilities here in terms of the values of the variable x, which is mass, right? So you have to convert x to z, okay? So the idea really is you want to identify you want to identify a variable, a normal variable, right? So we could say let x be the random variable, and I could give it in quotes or something. Yeah. The mass of a package, right? Then x follows a normal distribution with mean 200 and a variance 2, we put 2 squared, right? Because they say the standard deviation is 2. So this is what x is here. They want to know what is the probability that a package is less than 197. So what's the probability? What's the probability that x is less than 197? How do you do that? How do you do that? Well, you standardize. You standardize. This is the probability that z, well, let me write it like this. X, right, as a fraction, right? So x minus 200 over 2 is less than equivalent fraction, right? So this is 197 minus 200 over 2. convert this to a block equation. Let me see. Right. Right. So we standardize and we take where we do to one side of the inequality, you do to the other side. Remember, equality is for maths, right? If A is less than B, then A minus 4 is less than B minus 4. Or A minus 12 over 7 is the same as B minus 12 over 7. Wherever you do to one side, you do to the next side of an inequality. It's not an equation, right? So what is this probability here? What is this? Well, X minus mu over sigma is Z, right? This stuff here, that's Z. And what's 197 minus 200? Is it positive or negative? It will be negative 3. And then you have to divide by 2. So as this value here, 197 minus 200 over 2. This is negative 1.5. Right? So where's this probability as Z is less than negative 1.5? Right? That's what we need to find. Now the table don't give you for negative values, right? So you have to come here and look at a diagram. So we have something like this now happening, right? We want to know what is the probability that Z is less than some negative value. So that's the same as kind of what we did up here, right? You have to draw several diagrams, right? So let me come and steal all of this here. Right? Probability that Z is less than that is the same as the probability that Z is more than the positive value. Right? A comes like negative 1.5. Right? So pretend A is 1.5. Then negative A, so sorry, pretend A is negative 1.5. Then negative of A is plus 1.5. Right? So that probability as Z is more than 1.5. Again, the table can't give you that. Right? But that is equal to this probability here. Right? This modern probability right? Probability as Z less than negative is the same as probability as Z is more than 1.5 by symmetry. See, these two areas here are equal. Now, probability that Z is more than 1.5, which is this here, is equal to 1 minus probability that Z is less than a positive number. Okay? This one you could read from the table. So this here is 1 minus 5, right? Where's phi of 1.5? I read the table, so that phi of 1.5, let's go here. Where's 1.5? Let me see, 1.5, that's 1.50. That's 0.9, that's 9332, 0.9332. Right? That's really what that probability is there. Take this and put this up here, right? So phi PSZ is more than 1.5, which is this here, is 1 minus P is less than 1.5. Could probably duplicate this and put this here and take this out, right? Just to show you how I get in these things, right? Each equation shows a diagram, and then from the diagram we get an next equation by symmetry. See? So this is the answer here. The probability that the mass is less than 197, right? So I could come and say this here. Right? Okay, so the second part, what's the probability that the mass of our package is more than 200.5? So come down here, and does probability X is more than 200.5, right? So the same thing again, we standardize it, right? So X, you always subtract the mean and divide by the standard deviation. So you subtract the mean and divide by the standard deviation, right? But it's more than this time. That's what I want, right? So let's change the sign here to more than. Now 205 divided by 200 is 0.5. And 0.5 divided by 2 is 0.025. Sorry, 0.25, 0.25, sorry. Right? So this is what we want here, right? How does this look? Let's draw a diagram. How does that look? This is probability more than a positive value, right? See it here? That's a small probability. And the table cannot give you probabilities for greater than anything. The table only gives you probabilities for less than. So we need to change this around, right? Now we know, right? Don't need these things. We know from here. Probability that Z is more than 0.25 is equal to 1 minus probability that Z is less than 0.25. You see this area here, the red area, is 1 minus the white area, okay? So I could say this is 1 minus 5.25, right? What's 5.25? That's 5.25. You go in the table and you go 0.25, right? 5987. Okay. And subtract them, you get 4.4 something, 4013, that will be, right? And we could back that up with a diagram as well. Let me duplicate this. Put a diagram here. Right? Probability of Z is less than 0.25, right? If you notice here, watch. The pink area here is 1 minus the pink area down here, right? So the diagrams help you justify how to mix and match to find the area. And then we just continue with the working, right? So this one wasn't so bad. This package is more than 200.5 is 4013. There's the answer here. You'll understand that. So you see, you get a question with a normal distribution, you have to change it to the standard normal distribution in a process called standardizing. You can't use the tables with these values 197 and 200. You can't find those values here. Look, this is 0.5, 1.3. Look at finishing with 3.9. You can't find those big values here. So you have to standardize, right? When we standardize, we get some nice small values. And then it's the same game we played before. Draw a diagram to figure out two things. Is the area on the left or the right? And where's the value of, where's the Z value of the argument that you're trying to consider, right? Is it positive or negative? 0.25 is positive and we want the probability more than that. So, you know, you carry the table for 0.25 to get that small probability, but you could get the reverse one, right? You could do it in terms of the reverse, right? Always write the problem in such a way where you could use the table values to solve what it is you're looking for. How about this next one here? What is the probability of the masses between 198.5 and 199.5? This one a little bit interesting. This is kind of similar to the homework we had. If you look at the homework we had here, homework, right? Look at this probability. How to find, it's 3 questions I gave you, right? The first question, the probability was Z between 2 positive values. The second one, a negative and a positive value. I said draw a diagram for that and figure that out. And this one down here, probability that's between 2 negative values, right? It's called a band. The probability within a band is not very hard to find, okay? That's what I wanted you all to do for homework, how to figure that out. So we'll do an example here in this related question, so you could see how it's done. But try it for now. Try it, you know, what's the probability between 198.5 and 199.5? So we had to draw a diagram for this third part here, right? So we'll copy this. Let me go down here. Duplicate this. Do a new set of command. So it's 198.5 and 198.5 and 199.5, right? 198 and 199, both 0.5. So there's the inequality here. X is between these two things. Well, the other kind of write this out now. Right. It will look a little messy, right? So this is 198.5 minus 200 over 2, and this is 199.5 minus 200 over 2. This is something interesting. This is 0.75. This is Z. Right? 198.5 minus 200 as minus 1.5. And if you divide that by 2, you get minus 0.75 as this part here. This part here is 199.5 minus 200. Then we divide by 2. That's 0.5. Divide by 2 is 0.25. So we need a diagram for this, right? So this is how this would look. That's the area they want there. The other how you split that up, right? How you split that up is the, let's try it. So is the probability that Z is less than 0.25 minus probability that Z is less than minus 0.75. That's what it is. How I determine that? Probability that Z is less than negative 0.25 is everything from negative 0.25 to the left. So the entire area to the left after 0.25. And this probability here that is less than 0.75 is everything to the right, left of 0.75. So if you have this big area minus this small area, then you will end up getting the two, you will end up getting this area here in the region, right? So let me show you that in a diagram to convince you. Right, so the area here, how we do it, the area to the left of negative 0.25 is a bigger area than the area to the left of negative 0.75. This is the 0.25 area here. See, it's bigger than the 0.75 area. So if you take away the smaller area from the bigger area, you'll get the area in the band. So the bigger area is Z less than negative 0.25, okay? The smaller area is this here. So this is kind of what we need to find. Let's work this out down here now. How you would do this, right? Well, probability that z is less than negative 0.25. This is the same of probability that z is more than 0.25, right? And by a similar reason, this probability that z is more than 0.75, right? These two probabilities here are equal by symmetry, right? Less than a negative value is more than the corresponding positive value. Now, each of these probabilities here is a small probability. So this here, probability that z is more than 0.25. This is 1 minus probability that z is less than 0.25. And this one is 0.75. Right? Probability that z is more than 0.25 is 1 minus probability z less than 0.25 because this is a positive value. Same thing here. What would this work out to now? If you remove brackets, these ones cancel. And this negative by negative is a positive. So what you will get is the reverse of this, right? Probability z is less than 0.75 minus probability that z is less than 0.25. And you simplify this here. What's the probability that z is less than 0.75? We use tables for that. 0.75 here is 7734. Right? What is the probability z is less than 0.25? 5987. 5987. What is that now? 0.7734 minus 0.5987. 1747. That's the correct answer. Yeah. That's how you work this out. So I urge you to practice your homework. The homework was showing you how to deal with a band. Right? There are 3 questions. Yeah, draw the diagram for just one of them, not the other 2. You need to sit down and work this out and figure out what the values are. But this is how you would do this question. Now, to do this question, you don't need these 2 diagrams here as part of the solution. But you need at least this diagram to convince yourself which area to subtract from which area, right? But once you standardize, it kind of straightforward if you was following all the lessons up until now, right? So pretty much all kind of done with normal distribution, right? So we finish normal distribution, that's the P4. So we finish all the P outcomes, all the learning outcomes that required to pass, we finish that, right? Next Monday class, we will talk about statistical hypothesis and significance testing or hypothesis testing. That is the merit section. That'll be next Monday class. And next Monday will be your last class most likely, because that's just one topic, right? There's a good bit of notes. Hypothesis testing is not an easy thing. And we're going to do very simple hypothesis testing, which is testing a mean the probability that a value is close to a mean and a normal distribution. We talk about what hypothesis testing is, but again, the arithmetic is not hard, but the conceptual thinking is a little difficult, right? So we did a lot of work today. We did a lot of using the normal distribution, but you kind of had to wrap your head around it, how you use it to calculate probabilities. That's what, this is where we really ultimately where we need to. You're given a word question here, where you have some variable that follows a normal distribution. It has a mean, it has a standard deviation, and you need to calculate probabilities that that variable has a value within some range. It could be a less than, it could be a more than, it could be a band like this here, like this band here, okay? Anything they could ask you, and that's legit. So I hope you all understand how we did this question in example 3, right?